So we've discarded realism. What is locality?
So locality is the first idea is kind of Einstein's idea when he says he didn't believe in spooky action at a distance. So at the first pass, you say locality is saying that something that happens here, of course, you need locations for locality. The locations are in space or in space-time. So I have some object here. And the basic idea of locality is that the only way, first of all, this object can only immediately affect things that are very near it in space, right next to it. It can't immediately affect things that are very far away. So it's perfectly comprehensible how this can make that thing move because it banged into it, right? This is kind of the mechanical philosophy. The only way one thing can affect another is by literally hitting it. Yeah. And that means they have to be next to each other in space. If you were to say, if I were a magician, I can't do this, and I could move this, and all of a sudden that moved, you'd go, oh, that's magic. Now, there are lots of things that happen that kind of look like magic. I remember the first time I saw a remote control, I thought it looked like magic. I'm holding this little box and pressing, and then the TV is changing, and I grew up where you had to go and change the TV. But then you stop and you say, well, I understand, again, there's a beam of infrared light that's coming out of this box, that's going to the TV, and then that's also local because it's a chain of local events. The basic idea of relativistic locality or Bell locality is that if you think about it that way, if you think in order for me to press the button on this box, for that to have an effect on something way over there, something has to go from here to there. And now you add this restraint. It can't go faster than light. That's why it's relativistic causality. That the speed of light provides a limit to where my pressing this button can have effects in the future. They have to lie, as we say, in or on the future light cone. Otherwise, the effects would be superluminal. That's a clear constraint. And what Bell proved is that if you just put that constraint on your theory, just locality, local causality or relativistic causality, the theory cannot explain certain phenomena. And those happen to be phenomena that quantum mechanics predicts, and much more importantly, they're phenomena that actually occur in the world. The world does not obey relativistic causality. So that's locality. But the basic idea, I mean, Einstein's basic idea of spooky action at a distance is okay. You take Alice and Bob and you put them in two labs and you put them 100 million miles away and you say, well, nothing that happens in Alice's lab can really have an effect or make a difference to what happens in Bob's lab. Yeah. You can think of that as locality. And it's commonsensical. And the thing that Einstein objected to about quantum theory from the beginning was if you tried to take it seriously, it would be non-local. He saw that immediately, not to do with Bell, but he saw immediately that the way people were using quantum mechanics involved this non-locality because it came up immediately in what's called the collapse or reduction of the wave function, because the wave function for a single particle is sort of spread out all over everywhere. And it evolves usually by a nice local, for a single particle, it would be a nice local equation. You can understand it that way. But then sometimes it was supposed to do this other thing, collapse or reduce, and that happened globally and instantaneously. And for Einstein, that was spooky action at a distance. So you're saying an event happening here is affecting this wave function everywhere instantaneously. And he could never accept that. And he couldn't see any reason to believe it. I mean, the main thing for him was he said, why are you saying this? The phenomena don't require it. And the phenomena were simple things like you have a radioactive atom and you have a whole detector around it. And eventually a dot appears somewhere on that detector. You can't predict exactly where. Now, in the standard account, the wave function is, as it were, leaking out in a spherically symmetric way. There's bits of the wave function, if you will, all the time leaking out in all directions. And then at some point, for reasons they say cannot be explained, a spot appears here. Yeah. And that's weird enough. But what's even weirder is the moment that spot appears, there is no possibility that a spot will appear over here, right? A second ago, it could have, but the appearance of this spot is accompanied with the collapse of the wave function, which kills off any possibility of a spot anywhere else. And Einstein said, that's just silly. I mean, all that's happening is some particles being shot out in some random direction, right? We can't predict it. And of course, if it shows up here, it's not going to show up there. So what Einstein thought was actually the same thing the cubeists thought. They say, look, this isn't a physical effect, this collapse. It's just an epistemic thing. It's updating on new information. And of course, when I update on new information, I can learn new things about what's going on far away. Not because there's any physical change far away, but just my knowledge is changing. That's not spooky at all. And in a way, the motivation for cubism was to say, we don't like spooky action at a distance either, so we're going to treat the wave function, as I say, it's if the wave function is attached to my head and not to the object, then the collapses become trivial. They're just what we call Bayesian updating. You get some new information, you change your set of beliefs about the world. That's trivial, nothing spooky about it. That's what Einstein wanted to understand the collapses to be. But again, you can't relegate the wave function merely to being this set of beliefs because of things like two-slit interference, where the wave function is going through both slits, and it's important it goes through both slits and they interfere. And that's not about my knowledge. That's about something going on, in the lab.